Okay, this lesson will be about domain and a little bit about range, but mainly about domain. So the first thing we need to know with domain and range is what they're talking about. Well, domain are the possible x values, whereas the range are the y values that come from those x values. So if we're talking about a relation, so remember a relation is not a function necessarily, but just a kind of set of points or some type of gathering of information, possibly a graph, but not necessarily a function graph. So a basic relation would be something like this: 1, 2, 3, 4. Yes, I am making these up as I go, and 1, 3. So if we wanted the domain of these points, that would literally be every x value that's shown. Well, we have 1 and 3 and 1. Don't repeat them. Saying it once is enough. So our domain is just 1 and 3. Range are all the y values that come from those x's, like we said. So that is 2, 4, and 3. It technically doesn't matter if they're in order. We can say 2, 4, 3. Might as well say 2, 3, 4, but it really doesn't matter. Alex won't care. So that's basics of domain and range. However, there's other ways to look at functions or relations. They don't necessarily always come in sets like that. So another way is, I don't really have a name for it truly. If there's something like this, so one specific thing to watch for on these is where the lines come out of, that's the domain. Where the lines go into is the range. Generally they're set up domain range, okay? So these are really easy to figure out the domain and range of. However, I want to mention specifically what would make this a function or not a function is all dependent on the domain. If a domain member, right, has more than one line coming out of it, meaning, right, 1 could go towards 5 or 6. So like this. That is not a function, okay? Because, well, if you plug in 1, what do you get? How do you choose, right? Do you get 5 or do you get 6? Does it depend on when you plug in 1 or how many times you plugged in 1 already, right? There's no set way of figuring out when you would get 5 or 6. So this is not a function. If we only had one line like that, that's fine. If 2 went to 5 and 3 went to 7, that's fine. 1 and 2 can both equal 5. It's just 1 can't equal 2 different things, right? Plugging in 2 different numbers can give us the same value, but plugging in one number can't give us different values, okay? Just no way to make that work. So that's the difference between a function and a relation, or not a function, in this setup, okay? This is also something technically that would, if we graphed these points, would talk about if the vertical line test passed or not, right? Because if we look at a coordinate plane, if we graph 1 at 5 and at 6, well, that doesn't pass a vertical line test, right? They're right over top of each other. So that's kind of another reason why this doesn't work. That setup doesn't work. So after that is talking about graphs themselves. If you're just given points, right? Figuring out the domain and range again, write them out how that we first had that set, just as points, and take their x values and y values and write your domain and range. Not so difficult there. If you want to know if it's a function or not, just test with the vertical line test. You can do that with graphs, not just points as well. So if we had a graph like this, well, everywhere, right, we can run our pen along it. Everywhere that we take a vertical line, you don't go through the function twice. So that means it passes, and it is a function. However, if you have something like this even. This is definitely not a function, right? Because there's a whole bunch of places that it's over top of itself. So it doesn't pass the vertical line test. Now, some other points to talk about with domain, with function domain, is kind of exceptions to domains, or kind of what is an allowable domain. So, when we're actually talking about functions, full functions, like I was drawing before, the one that was a function actually, and we want to talk about what's the domain there. Well, that can get a little difficult, right? Because it's hard to write out every single value that's in the domain. So we use interval notation to write that out usually. And then if we're looking at a specific graph, we need to know what it kind of looks like to be able to tell. So if we have something like this, it doesn't even really matter truly what the values are. We just want to look at this and kind of figure out how to set this up. So with empty circles on the ends, well, interval notation means that those would be parentheses, right? And let's say that this was at -5 and 6, and then down here was -4 and 7, just to put values on it so we can actually write it down. That means our domain would be from -5 to 6, because it's all one piece, it's just one set. So -5 to 6, that's our domain. The range, we actually it sounds a little silly, but you actually want to look at it sideways, because you're going to look from the bottommost thing to the topmost thing. Okay, and again, there's no gaps or breaks in it, so it's one set. Again, endpoints are open circles, so parentheses, -4 to 7. One thing to mention on interval notation, they should always be in order numerically, so -5 should be before 6 and -4 should be before 7. Okay, so they should be in order always. Now, what happens if we have two different pieces? So say we had something like this. So, this, I'll just give it some values real quick. -5, -2, 1, -1, and 4. Let's see. This one, and that. Okay. So there's a whole bunch of numbers on there, but I think it makes sense what is for what. So, thinking first domain, from left to right, you always kind of read a graph. So we notice that there's a gap right here, right? So that means there's going to be two sets of intervals. So the first interval is -5 to -3. It's a filled circle, so that means a bracket on the -5. And the -3 is an open circle, so a parenthesis. We union the sets, okay, because it's both pieces. Now, next set is we're looking at x values, so 1 to 4 with a filled in circle first, so a bracket on 1, and then an open circle on 4, so a parenthesis. That's our domain. Now again, looking at our range, you want to look at it sideways, okay? You notice right here that they overlap, right? From 0 to -1, they overlap, meaning there's no gaps. So that means there's only going to be one interval here, okay? It doesn't matter that there's two pieces on this graph. It matters which sections on the y values that you have from those pieces. And because they overlap like this, there's no gap or break in it like there was in the x's, so there's just one set. So the bottommost place it goes to is at -3, and with an open circle, so a parenthesis. and it goes all the way up to 5 with a filled circle. So that's how we would write that out for that domain. Okay, so I started out talking about the exceptions, or kind of how to write out domains here, because this, right, was pretty easy to do because we were able to say, okay, this is specifically where the function is, right? So, but sometimes if they give us equations, right, we can't necessarily just look at those and say, okay, where is that function? Because, well, it's a lot of places. We want to think about it in the opposite way of where can't it be? So that means kind of where it's not allowed, or when kind of bad things happen or issues, right, pop up. Those generally pop up with fractions, undefined, right? What makes the fraction undefined? With the denominator 0. So if we have something like 11x minus 7 over x minus 2, well, what would make this not okay, right? If the denominator was 0, because that would make the fraction undefined. We literally don't care about the top. That could be anything it wants to be, right? It could be negative numbers, it could be 0, it could be positive numbers, right? The size doesn't matter on that because the numerator doesn't make it bad, right? Doesn't create an issue. Just the denominator can't equal 0. So, to figure out what value would make it bad, let's go ahead and set it equal to 0. Solve it out that way. So we add the 2 over, so x can equal 2. That's the value that is not allowed in this function. Okay, so how we would write this out, there is a problem that actually asks for what is not allowed in the function, but if we wanted to write it out in interval notation, what this domain looks like, well, think about it on a number line for a minute. We have 2 that's not allowed. So it's kind of like this section over here is good and this section over here is good. We just can't let 2 be in there, right? All the way to each of the infinities, right? Both directions. Because normally our kind of polynomial domain is negative infinity to infinity. We just can't let 2 be there now. So the way to not let it be there is with parentheses, right? Because parentheses don't equal. And we always parenthesize infinities because you can't ever reach infinity. And then you union the sets. That's how you kind of pull a number out of an interval. Okay? So that's one thing that's not allowed, right? We can't have 0 in the denominator. Another thing that's not allowed is we can't have a negative underneath a radical. So what I mean by that is if we had the square root of x minus 2, well, that can't be negative, meaning it can be 0, because the square root of 0 is just 0, that's fine, and it can be positive, because the square root of positive numbers, they might not be nice or pretty, right? They might be really long decimals, but they're still possible to do. So what we say here is x minus 2 has to be greater than or equal to 0, basically just not negative. And then, again, solve. So x has to be greater than or equal to 2, meaning it can equal 2, it can be bigger than 2, it just can't be smaller than 2. So the smallest number x can be for this function is 2, and it can be equal, like we said, so a bracket, and then it gets bigger. Well, getting bigger is going towards infinity. So the domain for this function would just be bracket 2 to infinity. So those are the possible domain issues that you have to watch for. Denominators can't be 0, and radicals can't be negative, okay? And it doesn't matter, so say we had plus 3 out here. That has nothing to do with underneath the radical, right? So that does not change the domain at all. Literally, my domain here is the same for this new function as our old one. Doesn't change one bit. Okay, that's domains.